Okay, so project management, okay, is another tools in operation management area. Okay, so it's a sub. It's a sub area in the operation management. Okay, alright. So project management. So it's project management. It's very wide. But in this chapter, I will explain to you very briefly and focus only one tools in project management. Okay. So this is the outline, okay, for this chapter. Okay, so you can see the example company, the company that use project management, okay, for the compete with the competitor. Okay, so we'll see what is the importance of project management, and then we focus more project planning, project scheduling, controlling. This is how we go very briefly. Okay, so project management and more to calculation part. Okay, right. So and then I will explain to you two techniques in project management. First, okay, program evaluation review and technique, and CPM, critical path method. Okay, CPM, critical path method. Right. And then determine the project schedule and the variation in activity times. Okay. Cost time trade-off ni I will not explain that. We will not cover in this chapter. Okay. Cost, crash cost. This is what we call a crash cost. Okay. Up to the variations in project activities here. Okay. No, this is not explained. Okay. So this is that one company that have a lot of projects and is known worldwide. Okay, so usually project management is mainly used in construction company. Okay, but project management tools is not necessary or necessary for constructing a construction building or construction area only. We can use in any area as long as you have a project. Okay. This is example of their project. Okay, they use so they really good in the project area. Okay. Okay, so this is what we will learn today. Okay. Gantt chart, and then we will determine the critical path and then calculate the various activity. Okay, that's all what we do today. Okay. So when I say project, okay, so what is project? Okay, what is the difference between project and the others? Okay, when I explained before in the previous chapter about product design, about the layout design, process design, when you want to determine the process, when you want to make a decision about what is your product, usually it's for long term. Okay, and it's continuously you will produce the same product. Okay, right? But for project, okay, so when we say a project, it's one not one activity. It's a single unit uh, not single activity, set of activities. Okay, but it must have a start and finish time. Okay, the duration. Okay, duration, and then when you complete that project, then that's it. Okay, maybe even though if you continue, but it's similar, not the same one. You just continue. Okay, not the same. You will not repeat. But if you produce the product, okay, let's say you produce a laptop, so you keep produce, repeat, produce and produce, and then after one time you will improve the design of your product, or you improve the layout. But project, if you have a very special activities, okay, different from the main business. Okay, so this is what project, the different. You have to differentiate between project and main business. Okay, project is something that quite different from your main business. Okay, so it has a start time, it has a duration, start and finish a project. Okay, right. So usually in project, okay, you have to plan many related activities. Okay, so related, then you have to make a plan. Okay, when you want to do this, okay, and then you at the same time you have to control your inventory. Okay, when you want to deliver the deliver the materials, okay, at the site. right? So usually in project, okay, you use a general purpose equipment, okay, GPE, okay, and need a high level skill, okay, focus in skills is very high skill, okay, you need a level high skill, okay, in construction is high level skill, right? So that is a project. So remember the main thing is about project, they have a duration, okay, then you have to manage this activity within the duration. You have to complete within the time. That's why it's quite complicated, okay. You have to complete it within the duration. If not, it will increase the cost, okay. That's why you have to proper planning and and you must control the inventory, okay. So this is example, okay, project, building construction, a research project, okay, research project you have start and then you complete, okay. You have others project lah, a lot of project in the business, okay. Okay, so in project, okay, to manage the project, okay, this is the main three things you have to do, okay, to manage the project. First, you have to planning, okay. You set your goal and then you define what is your project, okay. And then you form the team, okay, in your organization. Your team might be from the different areas, you need different skills, okay, right? So that is for planning. After you plan, and then you have to make a scheduling, okay. So you people, you have to manage the people, schedule people when who have to done this and when is it, okay. So funding, okay, you have to find the funding, okay. You must get the fund at the right time, maybe not at the lump sum at the beginning, but it's continuously based on stages, okay. So you have to schedule when you need to receive this at this stage, how much fund that you need, okay. And the supplies, okay. So different activities you need different supplies, okay. Right. Okay, sometimes the activity relate to each other, maybe you need a different materials, different supplies, okay. You need to schedule, okay, the materials, the peoples, okay, the fund, everything you have to make a scheduling at the right time so that you can complete within the duration, okay. And you have to control, you must control your resources, okay. Quality, control the quality, you have to control the budget, okay. So from time to time you have to revise the plan, okay, and then maybe you have to shift the resources. Maybe okay, instead of we do it now, maybe we can do later, or instead of we do it next week, maybe you can start now. Okay, then you have to shift your resources, and then based on cost, right? Okay, so that's you have to control everything. Okay, so this is the main elements in the when you want to manage the project. Okay, first planning, scheduling, and then control, okay, right? So see, plan objective, resources, and then you have to, in the planning also you have to do the work breakdown structure. You have to break down all the works and activities for each department, each stage, each in very details, okay, right? Okay, so in control schedule, then you schedule and then you control, do monitor, and then you revise and then you take action. Okay, right. So this is the three main activities. Okay, planning the project. Okay, okay, scheduling, sequence the access activity, assign the people. Okay, and then the supplies delivery. Okay, resources when you need that supplies. Okay. Right, so control the project. This is control. Okay, manage this, monitor the resources, and then maybe you need to revise. To if you have a delay, there is a delay activity. What you have to do, then you have to change your plans. Okay, right. Maybe you need to shift the resources, the workers, the materials. Okay, so everything that is the control during the project. Okay. Right, so usually planning and scheduling is before you start the project. Okay. Planning activity and scheduling the activity is planning and scheduling activities is before you start the project. So control during the project. Okay. Okay, so this is the tools that you need during each project, each activities. Okay, during the planning, you need to estimate time, budget, engineering diagram. You need to familiar with the cash flow chart. okay, material availability. This is all tools, okay, tools, we call it as tools to help you each during each activity, okay. During the scheduling, you have to familiar with CPM or PERS, okay, Gantt charts, milestone charts, cash flow schedules, okay, during to monitor the project budgets, okay. You need to prepare the delay activities report, what is the slack activity. This is all the tools for during each activities, okay. Right, so these three techniques, okay, I will go through very briefly about the Gantt chart. I will not show you how to create the Gantt chart, and then we go more detail about CPM and PERT, program evaluation and review technique, okay, PERT. Right, so simple Gantt chart. Have you heard about the Gantt chart? Okay, so this is the Gantt chart, okay, to show the progress. Okay, so you know when you start for each, you can start for each activity. You can design, you can start in January. So it's expected to complete in June. Okay. The prototype you can start in March and complete at the end of April. Okay. So this is the Gantt chart to explain the duration for each activity. Okay. Alright. So that's the usually project when you want before you start the project, you have to create the Gantt chart, a simple Gantt chart. Okay, even though your project is only for 3 months, you must have a Gantt chart also. So maybe your Gantt chart is by week, okay, weekly, right, or daily. Even you have a project, it's help you to monitor your progress. Okay, Gantt chart you can see. So suppose prototype you start in March and complete in April. If in the middle of April, do you think you can complete within at the end of April or not? Okay, so it helps you to monitor the progress of your project. A simple this Gantt chart. Okay. Okay, so you have to list all the activities. Okay. Okay, list all activity and the duration for each activity. This is to show when you will start that specific activity and when it will complete it based on the duration for each activities. Okay. Right. So example Gantt chart for service for a Delta jet. Okay, services. Right. So for passenger, the responsible for passenger, okay, when is the planning and claim, baggage claim, okay, when is it the duration, and then, okay, so this is the activities in the budget. Okay, so this is a software available, okay, but in this chapter, I will show you how to do it manually, okay. Usually when we say project, we have a very complex activities, okay. So it's quite difficult to do it manually, but even though it's not doing manually, you have to understand the basic things about how you want, when you want to plan your project. Okay. Okay. So the main techniques the most technique in the project management is a PERT and CPM. Okay. Right. So it's a CPM and PERT. Okay. Start from CPM and then PERT. Okay. Right, so CPM and PERT is using a network techniques. Okay, we want to plan the project based on networks. Okay, all right. So in CPM and PERT, okay, you have to consider. Okay, we have to consider the precedence relationship. Okay, and interdependency. It means that when you want to plan this activity, you have to identify the precedence, the predecessor activities. If you want to start activity A, so you have to identify whether you have to complete other activities or not. Okay, let's say you want to start A, and A can start at any time because before A you don't have anything, so then you can start immediately. Means that A don't have a predecessor. But let's say if you want to start activity G, okay, G, but before you can start activity G, you have to complete activity D first. Okay, so after D, then D complete, then you can start activity G. Okay, so this is explain the precedence relationship and interdependency. Okay, right? So it's depends to other activity, so that after that then we can start with the new activity. Okay, example, right? Okay, so example project, your project assignment project. Okay, so you have to identify the precedence relationship, which is what is the predecessor activity. Okay, let's say the activities um, in the project assignment. Okay, so first thing you have to identify your topics. Okay, alright. So before you identify your topics, what is it you need? Okay, maybe the direction from the lecturer. Okay, okay. So the direction from the lecturer, and then identify the topics. Okay, so after identify the topics, after you get the topics, then you can find the information. Okay, but you cannot find the information before you have your topics. Then can you start to find the information about the topics before you complete your topics? Okay, cannot. So that is a precedence and relationship and interdependency. It depends. To find the information, it depends to your topics. Okay, so when you complete the topics, then you can find the information. After you find the information, then you can start to write up your assignment. Okay, so that you cannot write up before you find the information. Before you get the information, you cannot start to write your assignment. Okay, alright. So after you write the assignment, after you complete the assignment, then you can bind or let's say print. Okay, so it means that you cannot print before you write up your assignments. Okay, so that is a precedence. Even though your assignments is also, that's why we sometimes call it an individual project. Okay, because it has a duration. Okay, you have to submit before week 13, let's say. Okay, you have to submit before week 14. You have to submit before study leave. Okay, it has a duration, but your learning activities, the class, the lecture, the continuous other assessment is not a project because it's continuously. Okay, and it's a main business, main thing. Okay, so project is only one thing, right? Okay. Then in the part, okay, in the part we have to estimate each activity. Okay. Example in your assignment project, so you have to estimate. So what time that what duration that you need to complete to determine your topics. Okay, let's say 1 day. Okay, so 1 day to find the information. So you have to estimate for each activity. Okay, the duration to find the information, we need 3 days. Let's say. Okay, so duration you have to do the estimation for each activities. Okay, right. So but CPM and PERT have a different methods to estimate the activity time. So I will show you later. Right. Okay, so this is a step in a PERT, same step. Okay, CPM and PERT. Okay. Right, so first you have to identify the work breakdown structure in each activity. Okay, and then identify the relationship. Just explain this now. Okay, a relationship between among the activities. Okay, which one is come first? Okay, and then the followed by the others. Right, so after you identify the relationship, the precedence relationship, okay, and the interdependency among the activities, you can draw the network. Okay, and you have to draw the network to connect all the activities. Okay, right, so after draw the network, then we assign time based depends to the measurement. Okay, if time and time, of course usually in CPM and PERT ni mostly we use a time. Okay, after time then it comes with cost. Okay, right, so assign the time to each activity, and then after we assign time for each activity, you have to compute to identify the longest time path. Okay, so the longest time path, this is what we call a critical path. Okay, this is theoretical. Okay, we will do it together after this. Okay, alright, so assign and then identify the critical path, which is the longest time path. Okay, and then after you get that, then you can use this network, okay, for you to plan a schedule and manage and control the project, okay, based on this network, right? Okay, so this is the most important, okay, to identify the project duration is based on the critical path, right? Okay, so this when you complete the PERT and CPM, okay. Okay, so usually in the PERT, after you complete the duration project network, okay, PERT and CPM, okay, so you will answer this kind of question. Okay, the project completion time. Okay, so with that, first you can identify based on that network that you draw, and then you identify the critical path, okay, which is the longest path. Then you can answer this question. Okay, when is it the entire project will be completed? Okay, the project completion time. Okay, and also that you can identify that what is the critical activities, okay, or task, means that okay, based on that network, after we draw the network, you can identify which one activities that you cannot delay. You have to complete within the time, okay. So that is the critical activities, okay. You cannot delay this. If the duration for these activities is 5 days, so you have to complete it within the you have to complete this activity within that duration, 5 days. Okay, you cannot delay. Okay, because if you delay, after you identify the critical activities, if you delay these critical activities, it will delay your project duration. Okay, let's say the critical activity 5 days, and your project completion time is 30 days. Okay. Okay, Lava, after this, okay. Alright, so after you identify the critical activities, then you identify the activity that cannot delay, okay? And then the next, when you can identify the critical activities, means that you can identify the non-critical activities, okay? So non-critical activities means which is the activities that you can delay, but only for certain duration, okay? So based on that network, you can identify which one is activities that you cannot delay, you have to complete within the time, and the activities that you can delay but delay within the duration lah jugalah, okay, that you have a duration that you can delay, okay. Alright, so what is the probability the project will be completed? I read this question, okay. Then also that you can answer this question, the probability that the project will complete within the certain duration. Okay, let's say after you identify your project will complete within the 20 days, okay, or 20 weeks. Okay, let's say 20 weeks. Then you can calculate the probability that this project can complete within the 25 weeks. Okay, certain time. Okay, so we can calculate that probability. Okay, alright. Okay, so that you can monitor, okay, whether the project is on schedule, behind the schedule, or ahead the schedule based on that network. Okay, so this is not covered in this chapter, but if you have a full complete PERT and CPM in the project management, you can answer this question. But I will not cover this. But up to number 4 only, 1, 2, 3, 4, I will explain to you. But 5, 6, 7, 8, then later, and we have another means that in the advanced level we have a project management one subject, okay, right, to explain all this, right. So also in the PERT and CPM, we can manage budgets, okay, whether we spend it equally or less than, or we spend more than fund that we get, okay. But we can monitor the resources, okay, whether the resources available or not, up to until the project complete. Okay, so and then the last one, if let's say we have to complete a project shorter than what given to us, so then what is the way that we will have to complete this? Okay, we have to accomplish this. Okay, let's say after we draw a network, then we identify that the project can complete within the 40 weeks, let's say. But the manager said no, you cannot complete within the 40 weeks. You must complete this project within 30 weeks. Okay. But based on that plans activities, you can complete within 4 weeks. But manager want you to complete within 30 weeks. So what you can do to shorter your project from 40 to 30 weeks. Okay. But this is more complicated, so I will not explain this, right? Okay. So by input and CPM, you can answer this kind of question. Okay, so this is example. So we will go to see we see how to calculate the CPM input. Okay, first CPM first. Okay, so this company, one company we have apa ni? What is the activities? Okay, so to install advanced computerized air pollution control equipment. Okay, so the project to install the advanced computerized air pollution control equipment in facility. Okay, so for this project, okay, to install the advanced computerized air pollution. Yeah. Okay, so they identify the activities and also the predecessor. Okay, so the relationship between each activity. Okay, so they identify to complete this project to install the computerized air pollution control equipment. Okay, they have 8 activities. Okay, build internal components, modify roof and floor, construct the collection stack, and then pour concrete and steel frame, building high temperature burner, install a pollution control system, install air pollution device, and inspect then test. Okay, so then means that is complete installation, right? Okay. Alright, so they assign each activity ni with assign the variable for each activity. Okay, A for A, B, C. So you can assign any variables. Okay. Right. So A for to build internal, E to build a high temperature burner. Okay, so they assign the variable for each activities. Alright, so then next identify the predecessor, precedence relationship. Okay, they identify that A and B can start immediately. Okay. Okay, A and B can start immediately, means that A and B doesn't have the precedence activity. Okay, you don't have when you want to start the project, you can start A and B immediately. Okay, means that when you build the internal component, at the same time you can modify the roof and floor. Okay, modify roof and floor. Alright, okay, badah. Ada ni hitam lah. C. Okay, can uh, C can start only when A finish or complete. Okay, so you can construct the collection stack ni when you complete to build the internal components. Okay, you cannot start C before you complete A. Okay, alright. But D can start only when A and B complete. Okay, if A only complete, you cannot start D. Okay, if B complete, A didn't complete, you cannot start D. Okay, so when A and B complete, then you can start D. This is how to read this table. Okay, I will explain how to read this table. Okay, but this table is given to you. You don't need to explain this table, but this is just for you to understand what does it mean by immediate predecessor. Okay, alright. So D can start when you complete A and B. Okay. Alright, so if even A complete, D cannot start. B only complete, you cannot start D, okay? When A and B complete, then you can start D, okay? So you have to wait until A and B complete to start D. Alright, C can complete, E can start when C complete, okay? E start when C complete and F also start when C complete. Okay, so when C complete, you can start E and F at the same time. Okay, so complete C, then start E and F. Okay, at the same time. Alright, so start G after D and E complete. Okay, you cannot start G when D only complete. You cannot start G when E only complete. So you have to complete. You can start G when you complete both D and E. Okay, and H also can start when F and G complete. So that's what does it mean by this immediate predecessor. Okay, right? So what this column explain to you. Okay, what does it mean, right? So this is how to read it. Okay, so this is time or duration for each activity. So duration for A is 2 weeks, duration for B is 3 weeks, okay, duration for C is 2 weeks, right? Okay, so duration for each activity. Okay, right, so now we will do a critical path method CPM, okay, or sometimes we refer to critical path analysis. Based on this method, we will identify the longest path in the network. Okay, so this path, okay, this longest path is will show you the shortest time that the whole project will complete. Okay, or the earliest project can be completed. Okay, all right. So like I said, okay, this will determine the critical activities. Okay, so means that if you delay any activities in this critical path, you will delay the whole project. Okay. Alright, okay, so this is I will explain you how to draw the network. Okay, so this is the table, the previous table. Okay, I put here. Okay, so first remember we will start the project. Okay, start. Okay, this is to draw the network. Okay, network. Then after that, identify the network, we can calculate the critical path. Okay, so before that, okay. So now, can you write in the chat area? Can you guess? So without looking to the next slide tu, okay, can you guess what is the duration for this project? Okay, based on this time, based on the time given to you for each activity, can you guess or estimate the duration for this project? Okay, right in the chat area. Okay, so how long this project for this company to install the advanced computerized air pollution equipment. Okay, so based on the time given each activity, can you estimate the duration for the whole project, for duration to complete this installation? Okay, just write in chat area. So please write the duration that you think to complete this project. just estimate what is the project duration time. Okay. Hello, can you hear me? Right lah, the project duration. So based on this duration, okay, for each activity, what do you think? What do you can you estimate the project duration, the time that you have to complete that this company can complete to install the air pollution? Right in the chat area, what is the duration do you think to complete this project? Why doesn't no one write any duration? Did you write it? Why is it no respond in the chat area? Oh, okay. Or give more time. All right. 40, 20, 25, 23, 20. How do you get 20, Faisal? How do you get 25? Or you just guess, or you just add everything? How do you get 25, Adam? And who else 35? Or you calculate the total is 20. Okay, lava calculate the total is 27. Aina 14 week. Suraya still calculating. Just sum up all the weeks. Why sum up lava sum up 27, you sum up 27, 25. 5, 11, 15, 25 lah. Itulah 25 sum up. Alah. Okay, so you sum 25, okay? Alright, but yeah, okay, if you sum out, so you have to remember that okay, we have a few activities that you can start at the same time. Okay, you can start at the same time. If we just sum up, means that that activities is start at different time. Okay, so that's why this network will help you to identify the critical the project duration. Okay, so first to draw a network. Okay, so first start. Okay, so we have two start activity. Okay, A and B can start immediately. Okay, this is to show that you can start the activity, the project. Okay, start. Okay, so we can start A. Okay, so this is A, can start immediately. Okay, we don't have any predecessor. And also B, we can start immediately. So A and B, we can start at the same time. Okay, A and B can start at the same time. C can start after you complete A. So A, after A, you can start C. Okay, so after A, you can start C. Alright, so after B, after D, okay, so C can start after A, okay, but D can start after A and B complete, okay. So A complete and B complete, then you can start D. Okay, so you have to arrow to D, two arrow to D. Okay, right? So A and B complete, then you can start D. Okay, so E can start after C complete. So now C complete, so you can start E, and also you can start F. Okay, so you can start E and you can start F after C complete. Okay, so after when you see here, after A complete, you can start C and D. After C complete, you can start F and E. Okay, G can start when D, okay, and E complete. Okay, so D and E complete, then you can start G. Okay, H, okay, H, you can start H after F and G complete. Okay, so F, G complete, start H. So after H, the end project. So project complete. To show, this is just to show that H complete means that the project is complete. Okay, right? So H complete. Okay, so let's see, project is complete at the end of the project duration. Okay, right? So this is the project network. Okay, this is what we call a project network. Okay, so to A and B start immediately. After A complete, you can start C and D. But D, you have to wait until A and B complete. Okay, after you complete C, you can start F and E. Okay, at the same time. Okay, so G can start only after you complete E and D. Okay, and H you can complete after you can start when after you complete F and G. Okay. Any question to draw this network? But you have to draw this manually, okay? Kalau I nak draw this manually in this ni zaman lah, okay? Take a bit longer time. Alright, okay, understand? No question, very clear. Okay, alright. Okay, so this is a still no project duration. Okay, alright. So then, okay, we assign each the duration for each activity. So A, 2 weeks. Okay, B from this table, A, B is 3 weeks. Okay, and then C is 2 weeks. Okay, so we just put in the network. Okay, D is 4. Okay, based on this one. E is 4, and then 3F3, okay, G 5 weeks, and also H 2 weeks. Okay, so we assign time for each activity in this network. Okay, in this network to help us to calculate later, right? Okay, so this is complete network diagram. Okay, you have a start and then to show the end activity. We will show the starting activity and ending activity. Okay, all right. Okay, so this is the previous diagram. Okay, start and end. Okay, so H is the end activity. So now we would like to calculate the we would like to identify the longest path. Okay, for this project. Okay, the longest path. Okay, so first we have to identify the path, first path, path 1. Okay, now you can see path 1 here. Okay, so path 1, this is the first path. Okay, we have A, C, F, and H. Okay, this is a path. Okay, continuously A, C, F, and H. Okay, so first path. So A is 2. A 2 weeks. Okay, plus C 2 weeks. Okay, so this is first path. Okay, plus F is 3 weeks. Okay, and H is 2 weeks. Okay, so this is our first path based on this network. Okay, so the duration for this path is 9 weeks. Okay, the duration to complete A, C, F, and H is 9 weeks. Okay, but we have to remember C, no, H only can wait when you complete G and F. Okay, but this path alone takes about 9 weeks to complete. Okay, right. So this is the path 1. Okay, path 2. Okay, path 2 is A, C, E, G, H. Okay, A. So you have to identify all of path. Okay, right. So A, C, E, G, H. Okay, so path 1, path 2. Okay, so A 2 weeks plus C 2 weeks. Okay, plus E 4 weeks. Okay, plus F G 5 weeks and H 2 weeks. Okay, right. So duration to complete all the activities in this path is 15 weeks. Okay, so that we have to identify the next path. You have to identify all path. Okay, so the third path is A, D, G, H. Okay, so A, D, G, H. A 2 weeks, D 4 weeks, G 5 weeks plus, and then plus H 2 weeks. Okay, so duration for path 3 is 13 weeks. Okay, 13 weeks, right? So path 4, okay, path 4 is B, D, G, H. Okay, so B, D, G, H. B 3 weeks plus D 4 weeks plus G 5 weeks plus H 2 weeks. So equals to 14 weeks. Okay, right? Remember, after we draw the network, then we can identify the longest path. Okay, so in this 4 path, okay, do we have another path? You have to identify until you have to calculate all path. Okay, so based on this diagram, I think we have only 4 path. Okay, so based on this 4 path, okay, the longest path is path 2. Okay, the longest one, 15. Okay, 9, 15, 13, 14 weeks. Okay, all right, so this is the longest one, 15 weeks. Okay, so means that this will determine the project duration. Okay, so the critical path is A, C, E, G, H. Okay, and the project duration is 15 weeks. Okay. So this project will complete within 15 weeks, not 14. No, that's why I ask someone write 14 weeks. How you get 14 weeks? Okay, it's near to 15. Okay, all right. So project completion time for this project is 15 weeks. Okay, all right. Not 20, not 25, not 24, not 23. It's a 15. Okay. And the critical activities, okay, critical path is A, C, E, G, H. Okay, so this is a critical activities. Okay, critical path. So A and C and E and G and H is the critical activities. Means that you cannot delay activity A, C, E, G, and H. Okay. A need to complete within 2 weeks, so you must complete A within 2 weeks. C must be complete within 2 weeks. You must complete C within 2 weeks. You cannot delay this activity. If you delay activity C from 2 weeks, you complete within you complete in 3 weeks. So the project duration cannot complete within 15 weeks. Okay, project duration you have to plus 1. Okay, on this 16 weeks. Okay, right. So project duration to install this computerized air pollution can be completed within 15 weeks. So you have to complete A, C, E, G, H within the duration is that assigned. Okay. Okay, right? And then understand the critical path. This is critical path method, CPM. Okay. First you draw the network, and then identify the duration for each path. Okay. And then determine the longest path. Okay. So the longest path means that is the critical path and the project duration. Okay. So the shortest time to complete the project is 15 weeks, not 9 weeks. Okay. 9 weeks cannot complete. You can complete this project only in 15 weeks, right? Do you have any question? Okay, don't forget to key in your attendance, Okay. Alright, understand how to get the project critical path. Attendance link, someone please copy attendance link. Identify path or how to do it. Yes, you need to draw this. Okay. How to identify the path from starting point. Yes, path from starting or from starting until at the end. Okay, it's not continuously from start. You cannot path cannot stop in the middle. It must. That's why I put start and end. Okay, so when you say path, from start until end activities. Okay. Okay, faham? Any there? No, Suraya? Is it clear? Okay. Yes, you have to draw this. That's why, okay, that when you say final exam, then this is another problem, okay? No problem. It's not, no, it's not problem. We cannot see this as, when we say problem, it's a negative way. Okay, we have to think furthermore. I need to think more about your final exam. Okay, all right. So that is for CPM. Okay. Okay. So right, go back. Right. So in this case, okay, in the CPM, we can see that the activity duration for each activity is you get the exact duration. For A is 2 weeks, C is 2 weeks. Okay, so usually there is a variations or variability in each activity times. Okay, sometimes the activity A can complete within 2 weeks. Okay, but maybe in another different time when you want to install this air pollution computerized air pollution, maybe A can be complete only in 3 weeks. Okay, right? Sometimes maybe A can be completed within only in 4 weeks. Okay, it depends to the situation. So there is a variation or variability in activity times. Okay, all right. So CPM only can use when we have an exact time or fixed time for each activity. Okay, but let's say you have another project. Okay, but you cannot identify exact or a fixed time for each activity. You can only have a variation about a few times. Okay, sometimes we can complete this within 2 weeks, sometimes in 4 weeks, and sometimes take 9 weeks to complete. Okay, so do you have a variability in activity times? Okay, so if that when you want to do that project, you have that kind of times for each activities. Okay, so then you can use a PERT. Okay, all right. So remember CPM only when you have the exact time or fixed time. Okay, so PERT if you have a variation in each activity's time. Okay. Right. So usually if you have the variation in activity times, okay, so you need to identify these 3 times only. If you have more variation, so you need to identify these 3 times. Okay, so the first one, you identify the optimistic time, which is the earliest. Okay, the earliest that you can complete that activities. Okay, this is time for each activities. Okay. Alright, so the earliest one, optimistic. Okay, let's say activity A, you can complete within 2 weeks, 4 weeks, 6 weeks, 7 weeks, and 9 weeks. Okay, so activities time is 2 weeks, the earliest one. Okay, alright, and pessimistic time. Okay, so pessimistic time is the longest one. Okay, so in this case, let's say 2, 4, 6, 7, and 9. So 9 is the pessimistic time. Okay, the longest one, the unfavorable. You only can complete within in an unfavorable condition. Okay, and most likely time. Okay, so most likely time is that most realistic. It's not the earliest one. It's not the optimistic one. It's like in the middle. Okay, between optimistic and pessimistic. Maybe in this case, 6. Okay, within the 2 or 9, and maybe 6 or 5. Okay, so you have to advise these 3 times only input. Okay, you need these 3 times. Okay. Okay, based on after you identify the remember okay, go back. Okay, so optimistic time we assign as A, pessimistic time B, and most likely time is M. Okay, alright. So based on these 3 times, we will estimate time for each activity. Okay, so how you want to you calculate you estimate time for each activity based on this formula. Okay, so this A, yeah. Okay, so A, remember this A is for optimistic time. Okay, so to calculate the estimated time for each activity, optimistic time plus 4. 4 is fixed, okay. 4 optimistic time plus 4 times by, this is the most probabilistic. Okay, most probabilistic plus the pessimistic time. Okay, optimistic plus 4 times most probabilistic plus pessimistic time. Okay, and divide by 6. Okay, 4 and 6 is fixed. Okay, why is it? They have they have do some adalah long to explain to you, but it's very complicated to explain. That's derived from something, okay. But this is a formula. At the end of the day, this you only use this formula to calculate to estimate the time for each activity for PERT. Okay, so this is to estimate activity time. Okay. Next also that when we want to calculate the project probability to complete within a certain duration, we need a variance for activity. Okay, so variance. So variance, to calculate the variance, V is for variance, okay. So B, pessimistic time minus optimistic time, okay. B minus A divide by 6 and squared, okay. Right, so this is the formula for variation, okay. So I will show you next how to calculate. Okay. Let me explain. Okay, so this is the same situation for Milwaukee project. Okay, to install what is a computerized air pollution. Okay, but this is, they have a variability times. Okay, all right. So activity A. The optimistic time is 1, most likely is 2, and the pessimistic, okay, the longest time to complete activity A is 3. Okay, all right. We cannot just take one activity, take only one optimistic. Okay, and also that we cannot take only most likely times. Okay, or based on pessimistic. No. Okay, in the PERT you have to calculate. Okay. Okay, so calculate to estimate each time using this formula. Okay, it's given in the previous slide, remember? Okay, let's say we do it for activity A. Okay, so A, okay, 1. Okay, all right, so 1 optimistic time.
Madam.
Yes.
This table they will give, or we must find all the values.
No, given to you. If in the exam, of course I will provide. If not, you will get a different time for each student. Okay. This table provided, but in reality you have to find. Do some research for each activity lah. Okay. But in exam, it's provided. Okay. You have to calculate this one only. Okay. You have to calculate ni.
Thank you, madam.
Alright. So optimistic 1 time plus 4 times 2 most likely here. Okay. And pessimistic 3 here. Okay. So divide by 6. Right? Okay. So okay. This is for B. Estimated time for B. T is estimated time. For B, okay, 2 plus 4 times 3 plus 4. Okay. Estimated time for C, estimated time for D, estimated time to calculate estimated time for E, and then estimated time for F, G, and H. Okay, can you get the estimated time for each, for A, B, C, D, E, F, G, H? Okay, calculate the estimated time. Okay, calculate. All right. Okay, so times, okay, estimated time for A is 2, estimated time for 3 plus B is 3, okay. So I hope you get the same time, 3, 2, and D estimated. This is, we call it as estimated time, okay. So because it's based on these 3 times. Estimated time for E is 4, estimated time for B is 3, G is 5, and H is 2. Okay, so this is estimated time for each activity. You have to calculate this. Okay? Any question? Okay? Okay, good, good, good. Total got 0.4 means, suddenly Google ni respond to my. Okay, got point. Okay, so point, if you got point, just take up to 2 decimal points. Okay, if not, just round up to the number. Okay, yes, can get, yes, can get the point form. Okay, don't worry, but take up to 2 decimal points only, right? Okay. Okay, so next we have to calculate the variation for each activities. Okay, the variation. Okay, B minus A divided by 6. Okay, all right, so 3 minus 1. Okay, so this is a variation for B, variation for C, variation for D, variation for E, F, G, and H. Okay, so after you calculate the variation, so this is a variation for each activity. Okay, I hope you get the same one, same figures, eh? Okay, right. Okay, so we put in the table. Okay, this table, the time, expected time. Okay, calculate previously and the variance here. Okay, you don't. If you want to answer, you don't have to transfer that time to table. Okay, the answer is already enough. Okay, don't waste your time, right? Okay, even though we have e-assessment, you have to do it online. Okay. So still, I think maybe I will give you a certain time, so you have to submit within a certain duration for each question. That's only briefly, okay? All right. So you don't have to transform that calculation into a table. This is just to show to you in a proper way, okay? So this is expected time, and this is a variance for each activities, right? Okay. If you compare to previous time, expected time, okay, this problem they try to put it the time for each the estimate time for each activities the same as previous one, okay. So then we don't have to do 2 times to calculate the duration. Okay, so still because it's the same. So if we repeat, if you get the same, if you use the different problem, then you have to redraw the networks, okay, and then identify the duration for each path, and then the longest path is the critical path for project, and then a project duration is based on the longest path. Okay, remember after you calculate that duration, you have to draw the network. Okay, all right, network, and then the same as critical as CPM, but only the difference between PERT and CPM is that you for PERT you have to calculate activities time. Okay, but CPM you don't have to calculate, you just draw directly. Okay, but in PERT you have to calculate the activity time. After you get the estimated activity time, then draw the network and identify the longest path, and that is the project duration and the critical path or critical activity in the critical path. Okay, all right. Okay, so now because it's the same, still 15 weeks, right? Okay, so let's say now in PERT, we can calculate the probability of project completion time. Okay. Okay, let's say, sorry, this is project variance. Okay, so project variance. Okay, so before we calculate the project probability of project completion, okay, you have to calculate the project variance. Okay, so project variance is the sum up variance for critical activities. Okay, in this example, okay, you calculate all variance for all activities. Okay, same as project duration. Okay, you add only, you sum up only the activities for critical activities, then you can get the project duration. Same as project variance, sum up the variance for critical activities. Okay, right? Right. So variance for activity A plus variance for activity C plus variance for activity E plus variance for activity G and plus variance for activity H. Okay, so this is variance for project variance 3.1. Okay, project duration is 15, project variance is 3.1. Okay, right? And the project standard deviation, you square root the project variance, then you can get the standard deviation. This is statistic. Okay, variance square root, then you get the standard deviation. Okay, so means that even though you find out that the completion project duration is 15 weeks, there is a variance in your completion times. Okay, you have to spare that there is a variance about 3 weeks in your project completion times. Okay, because of the difference time. Okay, all right, it's not an exact time, it's not a fixed time. You have a variation in time. So your project variance is 3 weeks. Completion 15 weeks, but the variance is 3 weeks plus minus 1.76. Quite high lah. Okay, the variation 3 weeks from the 15 weeks, you can say that is a little bit higher. Okay, alright, but it's okay. You don't have to. You interpret that. Okay, do that because this is reduced in another calculation. You don't have to interpret this variance. Okay. Alright. So let's say. Okay. What lah? Okay. Alright. So let's say this is why we have to calculate that project variance and project standard deviation. Okay, let's say we want to identify what is the probability that this project can be completed before the 16-week deadline. Okay, after you calculate the network, based on network, you identify that project duration is 15 weeks. But your manager said you have to complete this project within 16 weeks. 16 weeks means that it's okay lah. It's longer than your project completion time. Okay. Alright. So we want to identify the probability that this project can be completed on or before. Means that on or before within the 16 week lah. Okay. Within the 16 week deadline. Okay. Alright. So we will use the normal distribution. Did you I think in last semester, yes. In 3164, I think I already explained to you about normal distribution. Okay. Alright. So we for this one, we will use normal distribution. Okay. So calculate Z distribution. Okay. So the due date. Okay. What is the time that we want to see? Okay. 16 weeks. So due date is 16 weeks. Expected date of completion is 15 weeks. Okay. Divide by project variance. Okay, so that's why we have to calculate the project variance. Project divide by project standard deviation. Sorry. Okay, that's why previously we need to calculate the project standard deviation. Okay. Alright, so due date is 16 weeks. Due date. Okay, what week we want to look? We want to calculate the probability. We put here minus that the duration for activities. Okay, divide by project project standard deviation. Okay, so equals to when you calculate, you get 0.57. Okay, right? So this is still not the probability. Remember the normal distribution. Okay, then we have to refer to the. So this is how to write probability that duration less than 16 weeks. Okay. Alright, so 15 weeks, 15 is in the middle. Okay, if you draw the your normal distribution, the project duration is in the middle. Okay, the project estimated project duration is in the middle. The project probability time, so the one that you want to calculate is depends lah. If more than the project duration, then it's in the right side. If less than a project duration, in the left side. Okay. If got 14 weeks, if you want to see the 14 weeks, the probability that a project will complete within the 14 weeks means that 14 weeks is in this area, less than 15. Okay, so this is 14. Let's say, okay, if the manager want to see complete within the 14 weeks. Okay, more than the project duration in the right side, less than project duration in the left side. Okay, right? Okay, right? So now we have to refer based on this one, based on this figure. Okay, we want to identify the probability. If you remember, okay, this is in 3164. Okay, so this is from the calculation 0.57. Okay, 0.57. So where we get the probability 0.57. So this is 0.57. We see a 0.5 here and 0.57 here. Okay, 0.57. So the value is 0.7566. Okay, so the value was that is 0.71566. Okay, all right. So we go back to the distribution. Okay, so 16 weeks here. Okay, so the probability that that a project will complete before 16 weeks is 0.71566. Okay, so 0.71.57%. Okay, so 0.71566 means that 71.57%. Okay, we can see suppose if in the right side, okay, in the right side more than Okay, right side is a positive value. Okay, if you calculate this, okay, you want to know whether it's right side or left side. Okay, when you calculate, you get the positive value. Automatically, you know, is in the right side. Okay, more than half. Okay, the positive. Okay, so you should get the probability is more than 50%. Okay, if you get less than 50%, then it's wrong. Okay, more than 50%, right? So this is in the middle is 50%. Remember, one side normal distribution, the other half is 50, and the other half is 50. Okay, right? So 71% means that more than half. This is 16 weeks. Okay, 0.757. So the probability that T less than 16 weeks is 71.57%. Okay. All right. So all that we have calculated though, okay, what have we done before? What is the project management provide so far? Okay, so first we can identify that project completion time is 15 weeks. Okay, and there is a 71.57 chances that equipment will be placed in 16-week deadline. Okay, 71% that we can complete within the 61%. Okay, so 5 critical activity, A, C, E, G, and H. Okay, 3 activities is not critical, B, D, F, you can delay. Okay, because of a slack time, you can delay. Right, so and also that you can make a schedule, detailed schedule. Okay. All right. Any question? Okay, that's all for project management. So you have to understand to calculate for CPM, and then using a PERT. PERT is for PERT have variation in the activities time, and also that in PERT we can calculate the probability that project will complete within the certain duration, others than project completion time lah. Okay. If you complete within 20 weeks, then we can identify the probability that project will complete within 25 weeks, 17 weeks, less also can. Okay. Okay, ada question? Chapter 3, yes. Chapter 3 is in final exam. Which one difficult? Which one difficult? Okay. Don't forget to log it, key in your attendance, okay? Now I have 51, 50 lah, 50, but only 42 key in, okay? So in the last week, previous class also, same, about 50 attendance and 50 in this room, but only 45 key in the attendance, okay? And after I stop, after we complete the class, okay, I stay in a room about few minutes after that, okay? Not a few lah, lot, more than 10 minutes. I just stay on this room. And I can see that a few students still don't left the meeting room, okay? And no response. Probably that this is the risk. I mean that this the situation. I understand that when we do the online, there's some students that just log in the Zoom and then go and sleep again. I don't know. I'm not sure. Okay. Go somewhere, maybe help the parents or prepare the breakfast. I'm not sure. Okay. Okay. So the, I don't punish you. Okay. As I said before, after this, my attendance is solely based on what you key in the Google form, but don't pass it in others in outside from this room. Okay. I mean that is the loss for you. Okay. If you can watch the video, okay, if you can watch the video better compared to when you attend this room, so why not you just watch the video? You don't have to wake up early in the morning, log into the Zoom, and then you go back to the sleep. Okay, that is no purpose for to do that. Okay, because instead, besides the attendance from this room, I will also take the attendance based on when you watch the video. Okay. Lecturer can read your tactics, okay? Question 3 and 4. Let me see. Oh, 3 and 4, process layout. Okay, process layout lah. Process layout, yes, process layout is a little bit difficult because you have to do trial and error. Okay. In that case, you have to calculate. You have to draw. You have to draw the from to table. Question 4 is already given to you. Okay, from to matrix. Okay, but question 3 you have to calculate the from to table. Okay. Lawak, it's quite difficult. Okay, that's why you submit. Okay, and I will see where's the things that you don't understand. Okay, that's why I need you to do to submit handwritten. You have to do calculate. You calculate manually, and you snap and submit it to me. Okay. Which part you don't understand? Just try to answer what you okay, what you understand about process strategy. Okay, about how to calculate that from to matrix and then assign to the assign to the department. Okay. Okay, even though you can see the in the question 3, even layout is quite it's like in the floor, different floor, but you don't have to worry about the different floor. You can base on the distance. Okay, based on the distance only. Okay, distance and also the movement with the number. Okay, so you just assume uh, visualize as that still in the same floor but based on distance. Okay. Yes, you have to create the matrix for question 3. You have to create the matrix like a question number 4. So for process layout, first thing you have to create the from to matrix. Okay. Then based on that from to matrix, you assign the nearest the most distance and movement departments have to be the nearest. Okay. Distance and movement. Okay, not only distance. Okay, so distance and movement. Distance time movement. Okay, for each, and then because okay, let me share. Stop. Okay. Okay, so you have to calculate the distance and movement. Okay, you have to create the tables, distance and movement, distance time movement. Okay, so because this is distance from children to Chinese, okay, and Chinese to children. So from to you have to then you have from this is have different from and to, okay, but after you combine distance and movement, you have table combination from distance and move, okay. And the next table is a from to matrix. You have to combine from and to, okay, combine both to one only, okay, because we have to consider for both way. That's why you just combine, and the most highest distance and movement we put nearby, okay, side by side. First we got times by movement times by distance, okay, create one table, and then the next table from two, okay, combine from two, okay. And then chapter number 4 is already, you don't have to combine whatever, you just assign it, okay. Chapter question 4, chapter 4 block question 4. Okay, more complicated I think in chapter 3. If you able to do in chapter 3, chapter lagi aduh if you able to do question number 3, then I think question 4 is easy for you. Okay. So question 3 you have give you a raw data, so you have to calculate everything. Now 50, but 55 the key in. Does anyone key in 2 times? All right. Okay, if no more question, do you have any question? Okay, no question. That's all. I see you next week, Monday next week. Okay.